So a sample of brass consisting only of copper and zinc is dissolved in concentrated nitric acid. Now, we haven't done this reaction, so you're at this moment thinking, I don't know the reaction, but that's okay. Let's read on. So the first part is, what we have to understand is that the copper and the zinc have dissolved in the nitric acid. That's all we need to take away from that. Now, from there, we divide it into two samples. Now, sample 1 has 200 ml. And we react it with excess sodium hydroxide. This puts the zinc into solution. So the zinc ends up in solution, but the copper undergoes a reaction. So in sample 1, what's happening here is the copper ions undergo a precipitate reaction to produce copper hydroxide, which is then heated and converted to copper oxide. And we've got 3.005 grams. Now the zinc ions are still in solution. So this is allowing us to just find out how much copper is in this solution. So let's go through and do an example. So the number of moles of copper oxide, no matter what, you can always find a mole in these calculations, is mass over formula mass, which is 3.005 divided by 79.55, which comes out to 0.037777498 moles. And that's in 200 ml. But we want the entire sample. So the number of moles of copper in 200 ml is this. But we want 500 ml, number of moles of copper in 500, so we're going to ratio up 0.0377. And this gives us the number of moles being 0.094434746 moles. We can now find the mass of copper, which equals number of moles times formula mass, which is 0.094434746 times 63.55, which comes out to 6.00 grams. So this whole first section was how to find copper. Now the second section is how we find the mass of zinc. So in sample 2, we take another 200 ml and we treat it with sodium carbonate. So what this does is it actually precipitates to give copper carbonate, which is then heated and converted to copper oxide. And same thing with the zinc, we'd get a precipitate, which is then heated and converted to zinc oxide. Now their combined mass is 4.996 grams. Now because it's still a 200 ml sample, that means that the copper oxide is exactly the same as it was previously, which is 3.005 grams, because same size sample, same concentration, same everything. So the mass of the zinc oxide is going to be equal to 4.996 minus 3.005, which comes out to 1.991 grams. Now we've got a mass, we can find a mole. So the number of moles of zinc oxide equals mass over formula mass, which is 1.991 divided by 81.38, which is 0.02446547063 moles. From there, we can now find that's in 200 ml. So the number of moles of zinc in 200 ml is the same. Number of moles of zinc in 500 ml, we're going to ratio up. Which is 0.0611636768 moles. So we can find the mass of zinc, which is 0.0611636 times 65.38, and this comes out to 3.9988 grams. Total mass equals 3.9988 at 6, which is 9.9988. So the percentage of zinc would be equal to 3.9988 over 9.9988 times 100, which comes out to 40.0%.